Welcome back to NANDGAME. If you've been following along, you can see there's been a bit of an update to the way the levels are laid out, but that's fine for us. We are up to conditionals anyway, so let's start that, and we will go into AND. So no instructions here, we just have to write a function that does AND. This should work in a way that's very similar to the way we did the add and subtract functions. So we'll start by using push argument to push the two arguments to the stack. If you recall, the way that functions work here is values get pushed to the stack, and when you call a function, it will take those two values and put it in the args section of memory. So all we're doing here is taking it from the args part of the memory and putting it back to the stack to work with. We'll pop one of the arguments to D, pop the other to A, and then we need to AND them together. Now if we go all the way back to where we defined our assembly language, we should be able to do D and A to get the bitwise AND. So back in here, D and A, and then we just have to push our D value to the stack. And this should work. Let's try it. There we go, level successfully completed. Next level, OR. Again, no instructions here, but clearly we just have to write this OR function. And let's go back to AND and just copy what we have there, because we should be able to do pretty much the same thing, except for ANDing them together, we do OR, which is denoted by this little pipe operator here. Otherwise, the function should be exactly the same. So let's try it, and there we go. AND and OR, very similar to the way they're set up, and very similar to the way we did addition. If we go back here and look at add, you can see that function looks pretty much the same too. All right, on to NOT. Now this one is slightly different. It only takes one argument, and we do a bitwise inversion on it, and then push that result to the stack. So we can start the same way. We can push argument 1, or actually it should be argument 0 because it's 0 indexed. And then we'll pop that value to the D register. Now how do we do bitwise inversion? We'll go back here to where we made our assembly language. We can see that we can just do not D using this little squiggle. This is called a tilde, that little squiggle. So we can do D equals not D, and then just push that to the stack. And now in most programming languages I know, you wouldn't use this tilde, you'd use an exclamation, or sometimes you hear this called a bang, but here we're using the tilde. And again, this should work. Let's try it. There we go, level complete. So far we have just a few simple functions. Let's see if equals gives us any trouble. Again, equals, not much information here. It's called with two arguments. If the arguments are equal, we have to push this hex value to the stack. Otherwise, if they're not, we push 0. So there's a few ways to do this, but let's just start by doing what we've done before, and we push both arguments to the stack. And it doesn't really matter which order you push them in. And then we will pop these to our registers. And again, we do have to pop to register D first before we pop to register A, just because popping to D, again, if you look in here, will overwrite the value we have in our A register. But popping to A does not overwrite the value in the D register. So there's a few ways to do this, like I said, but the first thing that comes to my mind and the easiest is probably just to subtract. So we'll see D equals D minus A. And if this value in the D register is 0, then we know they're equal. If it's not 0, then we know they're not equal. Let's create a label down here, and we'll call it is equal. Again, up here it says if they are equal, we want to push this hex value to the stack. So let's set that to A. Oh, and it actually doesn't like that hex value. That is too big. But if you remember way back from 2's complement, this hex value FFFF should be equal to actually -1. We want to set D equal to A, and then push D. So now we'll check if D is equal to 0, then we want to jump to this is equal label. So we'll set the A register to is equal. And then if it's not, we want to set A to 0, D to A, and then push D here. Now the way that I have this set up here, it will continue down this path, which we don't actually want if it is not equal to 0. So let's set another label here called return at the end. We'll set A equal to return. Oh, and it does not like that return label, so we're just going to change it to end. And then we're just going to unconditionally jump to the end. So that way it jumps over this is equal portion of the code. Now we can simplify this a little bit, where I have A equals 0 and then D equals A. Now with most numbers, you can't set D directly, but I believe you can set D to 0 directly. That still works. And then I'm pretty sure you can also set D to -1 directly. So let's just do that and get rid of a couple lines. Somehow we have not in the function. I don't know if I did that or if it was just there by accident. Okay, let's try this out. And there we go, level successfully completed. Okay, I've added some comments here, and I will be sure to add this code in the same repository as I have all my other code for this game. So if you want to look at it a little bit closer, I'll put the link in the description. And it looks like with this redesign, there's a weird issue where these levels are duplicated. So I'm just copying and pasting from the levels I just completed. And this seems to be working. Last level equals again. And there we go, it looks like we have a new set of levels available. I believe in the old layout these were called optional levels, but we'll work through them, and next time we'll do the transistor level. And who knows, maybe there'll be another update before then. So I'll see you there. Thanks for watching.